Hey everyone, we've been talking about how to write and do arithmetic with imaginary numbers. And now we're going to go back to the quadratic formula and we're going to use that to find solutions that are going to be imaginary values. So these would be, in the case of a graph, these would be graphs that if we were to go ahead and graph it on a grid, it'd be something like this where the quadratic doesn't actually touch the x-axis. So something like that maybe, or something like this, just doesn't come into contact with it. So we're going to look at a couple examples, and you'll see the similar steps that I took in the first assignment, and we'll have to focus a lot on the discriminant and the part under the square root because those parts are going to be negative. So we got to make sure we factor out that I. So for this first one here, same way we talked about before, I'm going to write down my values for A, B, and C. Then I'm going to go ahead and start substituting them into the calculator. So I'm going to have -4 in for the first B. Under the square root sign, I'm going to have -4 squared minus 4 times 1 times 29. And that's all going to be over 2 times 1. So I'm going to simplify each part. So I have 4 plus or minus. I'm going to pull the calculator out right now. So we got, in this case, for the second part, we got -4 squared minus 4 parentheses 1 parentheses 29. So in that case, you have -100. And that's all going to be over 2. Now, I know that the square root of 100 is going to be 10, but we have that -100, so that would be the same as -1 times 100. So for that part, I have I for the -1 and 10 for the radical 100. So that means that this is going to be 10I divided by 2, and then I can divide the whole numbers each by 2. So after I divide each of those numbers by 2, I'm going to end up with 2 plus or minus 5I. So again, remember there's two possible answers for this. There's 2 plus 5I and 2 minus 5I. Those are going to be my solutions. Now, moving on to the next example. And in the case of A, pretty similar to the ones we've done before. Really what you want to make sure you do is get your terms on the same side. So I'm just going to do that first part for this. I'm going to subtract the 7x. And I'm going to add the 10. I'm going to make sure I add them to the like terms. So those cancel out. I end up with 0 on the right. We have x squared minus 12x plus 40. And then again, A is going to be 1. B is going to be -12. C is going to be 40. So I'm going to go ahead and start putting those into the formula. I got -12 to start, and for the first B, my square root sign, I'm going to have -12 squared minus 4 times 1 times 40. That's going to all be over 2 times 1. So I have 12 in the first part. Now I'm going to go ahead and type that in my calculator. So I got -12 squared minus 4 parentheses 1 and then 40. So we have -16. And that's all going to be over 2. So again, radical -16 is going to be -1 times 16, which in this case would be 4I. So this is going to be 12 plus or minus 4I over 2. I can divide each number by 2, so I get 6 plus or minus 2I. And then again, there's two answers. It's 6 plus 2I and 6 minus 2i. So those are my solutions in this case. Now we're going to kind of tie this into the graph itself on the next page. So I'm going to go ahead and erase this. Now our next example, we have a is 1, b is negative 6, c is 13. So I'm going to throw that in the formula. So I got negative 6 in for the first b, plus or minus negative 6 squared minus 4 times 1 times 13. And that's going to be all over 2 times 1. So I'm going to have 6 plus or minus. In the case of the radical, we're going to get negative 16 for this part, and that's going to be over 2. So that negative 16, like we just talked about, is 4i. So this will be 6 plus or minus 4i over 2, which ends up being 3 plus or minus 2i. So we got 3 plus 2i, 3 minus 2i. So they want us to do a sketch of the parabola on the axis, and they want us to use the window that was indicated. So I'm going to go ahead. First I'm going to type in, we got x squared minus 6x plus 13. Now they want me to switch the window around, so I can press the window button. And it looks like my x minimum maximum are negative 5 and 10, and then for the y minimax I got negative 5 and 20. So I'm going to go ahead and pull up my graph to kind of see what it looks like here. Okay, so you can kind of see what the sketch looks like. I'm going to pull up some points. I'm going to focus on the y-intercept, which is 13. So we got 0, 13. And one thing you'll see that's interesting is we have a turning point at 3, 4. So this graph is going to look something like this. So as far as part C goes, for your answers for A and B, what can be said about the parabolas whose zeros are complex roots? Well, you notice that the first number itself, that 3, is the x value. And if we were to take those I values, that 2i, and square it, we'd end up with that y value. So that's going to be our relationship with these two roots and how it's kind of related to that vertex point. So again, like we talked about before, if you look at exercises 4 and 5, it talks about the discriminant. If you have an x-intercept, again, you're going to have a value of 0 or above. In the case of imaginary values, there is going to be no point where your graph touches the x-axis. So if you do have a negative discriminant just means there's going to be no place where you touch that x-axis. So if you do get a negative for that, look out for that case, okay, as you're looking at the problems that go on from here.